All right, hi everybody. So over the weekend, your problem set that I was looking for was the worksheets 1, 2, and 4. So when I was checking things on Sunday, those were the things I was looking for in your OneNote. So if those weren't there on Sunday, or you thought they were, and I marked things incomplete, and you're like, they should be there now. You know the drill, right? You send me an email, let me know after you've got them put back in there, and I can update things. Everybody gets a week of grace, so it's no big deal. Today I'd like to start by taking questions from worksheet 4, because if you were to have a homework quiz soon, the kinds of questions that would be on there would be questions from worksheet 4, which is just a mix of 1 and 2, right? It just makes those same questions mixed together. Maximus.
Just like number 11.
Number 11. We'll start there. Ellie, you're next. Cool? You got it? Okay.
Can we wait 1 second? I'm not gonna shoot you around. And worksheet 4. The back of worksheet 4 is
It's just mislabeled.
we have 3 worksheets. Where you worksheets here?
And problem 11.
Okay, so problem 11 says secant theta equals -2 root 3 over 3. So my first thing that I want to do is I want to rewrite this problem so it's not a secant problem, but rather a sine, cosine, or tangent problem.
Yeah.
Okay, so I remember from like our first unit that secant is the same thing as 1 over cosine. So far, so good. Now, what I'm going to do is instead of 1 over cosine, I want regular cosine. So I'm just going to flip both sides of the equation. As long as I do that to both sides, it's okay. So notice I just flip both sides of the equation and turn it into a cosine equation now instead of a secant equation. That's step 1. First thing I want to do is get it out of one of these reciprocal identities and into, a sine, cosine, or tangent. Next thing I want to do is try to determine whether this is a problem, bless you, that I should be using a unit circle for or my calculator for. Because again, the directions say give an exact answer if possible. Otherwise, use your calculator and round to 2 sig figs. So if I look, this certainly is formatted in the way that I would expect it to be a unit circle question, because I see like square roots and a fraction and stuff and not like a decimal, right? But if I go and I look at my unit circle, there is no coordinate on my unit circle 3 over 2 root 3.
So you just do.
So I'm going to rationalize this denominator. So we'll multiply the top and bottom by root 3, because I notice there's a square root of 3 in the denominator. And then those 3's can reduce out. And square root 3 over 2, well, I guess negative square root 3 over 2, really. That's a unit circle coordinate. So I'm for sure a unit circle problem here. Everybody good? Yeah. All right. So the next thing I want to do is identify where on my unit circle I want to be looking. So I know here that because cosine is equal to negative root 3 over 2, I know I'm looking at where cosine is negative. Max, you still good?
Yeah.
Okay. Oh boy, that's not what I want to see there. So cosine is negative.
That'd be S and T, right?
Yes, sir.
Yes, sir, my boy.
So A is for all of are positive. C is for cosine is positive. So the other two places, S and T, are where we're looking for cosine negative.
It'll be T and C.
Well, then I want to look at my interval and figure out what quadrants are covered by that interval. So I'm going to do the same thing. I'm going to start on the positive x-axis at 0. And which way am I counting? Clockwise or counter? Counterclockwise, because the angles are positive, right? So I have a half, 1, 1.5, 2, 2.5, 3, that's my start, 3.5, 4. So from 3 to 4 was covered by those two quadrants, T and C, as predicted. So what quadrant does my answer lie in?
3.
Quadrant 3.
So we said pi over 6.
So on the unit circle, in quadrant 3, we're going to look for the angle where x is equal to negative square root 3 over 2. Which again, I heard somebody mention, but let's just pull out our unit circle and just look. So we're talking about this spot here in the third quadrant, the x coordinate, negative root 3 over 2. So the answer we're looking for, the angle we need is 7 pi over 6. Everybody's okay? But there's one little problem still left here. 7 pi over 6, that's like 1 1/6, right? 7 over 6. Is that between 3 and 4? No. Oh. What do we do?
2 pi.
Good. We're going to find an answer coterminal to that 7 pi over 6 that does lie between 3 and 4. So we're going to be either adding or subtracting 2 pi. Ian, you said to add 2 pi. How did you know we had to add instead of subtract?
Because it's under the lowest that the...
Perfect. Yeah, 1 1/6 is too small, so we need to make it bigger. So we're going to add 2 pi. To add 7 over 6 and 2, what do we need to have? Common denominator. What would that common denominator be? 6 is right. So we have 7 pi over 6 plus 12 pi over 6, which gives us 19 pi over 6, which is, as a mixed number, 19 over 6 is 3 1/6, which is definitely between 3 and 4. So we are good. That is our answer. Max, did you feel good on what we did there? So that first step where we take these reciprocal functions and translate it into a sine, cosine, and tangent equation, that is a necessary first step. You got to do that. But after you do that, it just becomes a page 1 problem now. And you can do it just like you did the problems on page 1. You just have that additional, got to rewrite it as a sine, cosine, or tangent step. Ian.
Can you do 9?
Yeah. Is everybody good on 11 before I move forward? Yeah. Okay, Ellie, you had a question before. Was that not a real question? Okay, I just wanted to make sure that I didn't forget about you before I go and I take a new one. All right. So we're going to do the same thing. What is the tangent is the reciprocal of what? I'm sorry, cotangent is the reciprocal of what? Yeah, I said I kind of gave it away there. And then we'll flip both sides. So far, so good. So we know that tangent here is negative. So what quadrants is tangent negative in?
S and C.
S and C. And then we need to figure out what quadrants are covered by the interval from negative 5 pi over 2 to negative 3 pi over 2. Notice this time our angles are negative, so I'm going to be going which direction?
Down.
Clockwise, which is down first, yep. So negative pi over 2, negative 1, negative 3 pi over 2. That's the start. Negative 2 pi, and then negative 5 pi over 2. So we were covered then by, nope, wanted. Come on now.
It's not in draw mode.
I mean, it is. It just doesn't.
It just
It doesn't
didn't
want
wanna
to think about it. And I said, oh, that was these guys, right?
How do you know which side to,
Because as we were going this direction. So we started here and we end there. So it's just like you got to keep thinking as you're spinning around, right? Oh, and I guess we should pause for a moment and ask ourselves, is this a unit circle question or a calculator question?
Yes.
Yeah, as soon as I see the square roots of 3 in there, I'm thinking it's a unit circle question, or a square root of 2, or any square roots in there.
How did you get like the 4 numbers like S and C and S?
So I am just starting on my positive x-axis at like a 0 degree angle or a 0 radian angle, and I'm just counting this out. So because it's a negative angle, I'm going clockwise. Every quadrant is like 90 degrees or a pi over 2. So that's like negative pi over 2, negative 1 pi, negative 1.5, negative 2, negative 2.5, and I'm just counting around. Does that make sense?
Yeah.
So we are a unit circle problem. And we are looking in quadrant 4. And we're looking for where y over x is equal to negative square root 3, right? Okay with that? Or I could think about it as negative square root 3 over 1. Because there are no square root 3's by themselves on my unit circle as a coordinate, right? They're all like square root 3's over 2. So what I'm going to do here is I'm just going to think about like, oh, what if I just multiply the top and bottom by a half? Right? What if I think about it that way? So what this tells me then is that my x should be now what I picked, my x should be like plus or minus a half, and y should be plus or minus 3/2. Now keep in mind, because I think that because this is a negative, I don't know where that negative sign goes to, whether it goes with x or y, so it could be with either. but that's what I'm looking for. And I really should say, like, because it's negative, I know that one of them has to be positive, the other has to be negative. I can't have both the same, right? So I'm going to go to my unit circle and look in quadrant 4. And I'm looking for where x is a plus or minus half. Well, if I look at my x's, there's my only place where x is a half. And the y is negative root 3. That's great. So the angle I'm looking for is 5 pi over 3. Everybody's okay with that? You could have guessed and checked that too, rather than doing some of the gymnastics I did there. What's the problem though? Not too small, too big, right? My answer needs to be negative, that's a positive, right? So what do I need to do? Minus 2 pi. So to do that, I need a common denominator. Yeah. I get negative pi over 3. Is that between negative 2.5 and negative 1.5? No, right? It's still too big. What do?
Let's do.
Subtract again.
Smooth out.
So that gives me negative 7 pi over 3. Notice negative 7 over 3 is like negative 2 1/3, which is between negative 1.5 and negative 2.5. So I know that's a good answer. Is everybody okay? If I'm finding a coterminal, I'm just going to do it like one shot at a time, right? Is this feeling better?
Yeah.
Should we do a calculator one?
Yeah.
Okay. Anybody have a preference? We haven't done a calc. We've done 2 unit circle ones. 10, says Ian. That sounds fine with me. Although I'm running out of space here. Can we do 8 instead? Okay, it's like the same problem, right? It's like whatever. Just kind of used up the space for 10 here on myself. If it doesn't make any difference, this will be a little cleaner. All right. So we start the same way. That's 1 over cosine equals negative 3.4. So cosine equals negative 1 over 3.4. Now, is 1 over 3.4 is a decimal, but I don't care what the decimal is. It's so much easier just to leave it as that. Because it's not part of a final answer. I can type that in my calculator much easier than whatever cockamamie decimal that turns out to be. I'm just going to leave it. Decimal in the fraction, fine. Not part of a final answer, totally fine to just leave it. It's easier and cleaner for now. So I know cosine is negative because it's negative 1 over 3.4. So where is cosine negative? Over there. Then we'll look at 5 pi to 6 pi. Since this is positive, we're going to be counting counterclockwise. And I just count around just like I did before. Just got a lot of counting to do this time. Yeet! There's 5 pi, there's the start. And there's 6 pi, there's the end, so we covered these 2 quadrants, right? Everybody feel okay on how I got to there? Now, if this is a calculator problem, clearly, right, because I have a decimal, like 3.4 is not a unit circle value. So what I have is, I'm going to draw my angle. So the terminal side needs to be in quadrant 3. And when I did that, I went around 2 times before I ran into my answer. So that's my theta. And then I'm going to use that picture that we had drawn and we had put in our notes, right? Now, if you don't have that written down in your notes, you definitely want it. That's something that I would put on my note card because that tells us for all these calculator problems how to find your final answer, right? Once you figured out the quadrant your answer is in, that picture tells you how to write the equation to get your final answer. So we're in quadrant 3. So we're going to say that theta equals x2 plus alpha. Now, what is x2? It's the label we gave on the x-axis when we did that. In our picture, that was 5 pi. Everybody good so far? And then we need to figure out what alpha is. We find alpha the same way. We're just going to be using this equation. So alpha is going to be cosine inverse absolute value -1 over 3.4. And now it's going to be calculator time. Let me grab that. No, I'm pretty sure I asked for this thing. Pull this guy out. Okay, so we're going to do 5 pi minus cosine inverse. And I'm going to do the absolute value in my head. Yes, sir.
Plus. It's X.
Oh, yeah. Okay, quadrant 3. Yep. I forgot what quadrant we're at. Thank you. Okay. I'm going to do the absolute value in my head. So that's just 1 over positive 3.4. Again, the calculator can do the absolute value for it, but like, you don't need the calculator to do an absolute value of a number, right? It's like, Mr. Gulick, I can drop negative signs all on my own. I'm used to doing that. I do it sometimes without even needing to do it. I do it just so I can get extra points off on my problems, you know? So my answer I'd write would be 16.98. Now I can check that answer, and you should, right? This is a relatively complicated process. We had to do kind of a lot to get here. All of these answers are checkable. So the check is 2 parts. First part, I want to do cosine of 16.98. and see if I get negative 1 over 3.4. So cosine of the answer. I get this decimal. Is that negative 1 over 3.4? Well, I don't know, not by looking at it, but I'll just type in what negative 1 over 3.4 is, and I don't know about you, I'm convinced that's the same answer. Everybody agree? That's part one of our check. We still have one more part to check. The other part that we need to check is to make sure 16.98 is between 5 pi and 6 pi. Right? Because our answer needs to be between 5 pi and 6 pi. Well, 16.98 is bigger than 5 pi. That's good. And it's smaller than 6 pi. That's good. That tells me my answer is correct. So the check is two parts, right? You have to check that it satisfies the equation, and then second, that it satisfies the interval that you're solving over. Should you ever write down a wrong answer on a test or quiz? No, because they're all checkable, right? Now, like if you're like, dude, I've checked this and like redone the problem twice and I can't figure out where I'm making my mistake, it's better to like leave the work and I can see what you've done. Maybe put a note, be like, I know this answer isn't right, but I can't find my mistake. That's fair. That tells me at least like you know your answer is incorrect, that you checked it. Like that's demonstration of understanding. Even if you're like, I couldn't figure out what the mistake was, that tells me something, right? I can give partial credit for something like that. You guys get what I'm saying? The partial credit is on demonstration of understanding. So if you show me that you understand that, like, I know this is the process, I'm pretty sure I've done this right, I know how to check it, but I'm not getting the right result when I check it, but I can't find the mistake, I went back and I looked, that tells me stuff, right? That tells me how well you understand what's going on, which is pretty well. You probably just have like some drop negative sign, or you did some little arithmetic whoopsie, and sometimes those are hard to find when it's, you know, when you're looking for it on your own. What do you guys think on this worksheet 4? Does it feel better? Okay. So if you were to have a homework quiz in the near future, and it contained problems similar to these from worksheet 4, you'd feel okay about doing them, about how to start them?
Yeah.
Okay. Just checking. If that were to happen, you know, like later this week or something. Today, what I'm going to assign for you guys is the 1 through 18 from the book problems. Now, 1 through 6, we already know how to do, right? We're just going to use our unit circle and the fundamental range for our inverse functions and find the angle, right? Like sine, I'm looking between negative pi over 2 and positive pi over 2. Cosine between 0 and pi. Tangent between negative pi over 2 and positive pi over 2. Like that's all. 7 through 10, just typing this into our calculator, right? Beep, boop, 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 beep, enter, done. 11 through 14, I don't know how to do that yet. 15 and 16, these are just like worksheet 4 problems where I've given you something to solve, an interval to solve it over. And in fact, these are easier because some of these intervals are only one quadrant. That's nice. And then 17 and 18, I don't know how to do that yet either. So today, we're going to talk about how to do like 11 through 14 and 17 through 18, because everything else in this set are things that we've done already. Is everybody okay? That's the focus for today. All right. Oh, I got to do some cleanup here first. Yes. Sorry, I thought I'd done this already. All right. So before we dive in, a little piece of notation. You might have noticed on some of those problems, we also have like arc sine or arc cosine or arc tangent or whatever. Means the same thing as like sine inverse, cosine inverse, tangent inverse. Arc just means inverse as far as we're concerned. Those two notations can be used interchangeably.
Same thing as like the worksheets. That's the like cos the inverse cos.
Arc cosine means cosine inverse.
Yeah. Worksheets is like the entire thing. It's just arc inverse.
Worksheet 2 is like the same thing you're doing at worksheet 1, just without units or something. Yeah, it's still the same thing. You're just using a calculator. So it's just like the example we just did. We can talk in a minute. In fact, I'd be happy to talk with you in a minute, get you going. All right. So what I want to talk about here first is these problems that are like a composition of a trig function and an inverse. So our first example, the inverse is on the inside of the composition, right? We're doing cosine of the inverse. In the second example, I'm doing sine inverse of tangent. There, the inverse is on the outside. Yes. Now, all of these sorts of problems I'm going to give you, these are all unit circle problems. So we don't need a calculator at all to do any of these. So what I want to do is I want to start by working on the inside. So I'm going to take the inside part. Everybody's okay? Now I remember that the fundamental range for sine inverse is from negative pi over 2 to positive pi over 2. So I'm going to use that now to find this angle. So I know that sine is negative. So where is sine negative? Yeah, quadrants 3 and 4. And then we need to identify what quadrants are covered from negative pi over 2 to positive pi over 2, Nick? Why is sine negative? It's not. Come on, Mr. Kulik. You're being a doofus. Sine is positive because it's 0.5, right? Thank you, Nick. Good job. Appreciate you paying attention. Sorry about that, everybody. Sine is positive because it's positive 0.5. Thank you. Now notice that one end of my interval is negative and one end is positive, right? So starting at 0, we have to go clockwise down to negative pi over 2. And then starting at 0, we have to go counterclockwise up to positive pi over 2, which means that we covered quadrants 1 and 4. Everybody feels good there? Okay, so I'm going to say on the unit circle, in quadrant 1, we're looking for where y is 1/2, because that's the same thing as 0.5, right? If I take out my unit circle, y is 0.5 when it's pi over 6. Pretty good? Here. So this pi over 6, I can replace the sine inverse. So we have now cosine of pi over 6. Everybody okay with that? So I figured out what the inside was. The inside's pi over 6, and now I have cosine of pi over 6. How do I do that? I just go back to my unit circle. I find pi over 6, but this time I want the x coordinate because we're doing cosine of pi over 6. So my answer should be root 3 over 2. Everybody feel okay?
Once you get the first part done, it's really
Yup. The inverse is the hard part. The regular trig function is the easy part, typically. So wherever the inverse is, that's the part that's difficult. Looking the value up off the unit circle, I mean, that's relatively easy. Yes?
Can you tell me how to get out of pi over 6 again?
Yeah, so on the unit circle, I looked in quadrant 1 for where y is equal to 1/2. So in quadrant 1, looking at where the y is 1/2, pi over 6. Does that feel good? Good. Okay. On to example B. You guys good? So again, we start from the inside. So I want to do tangent of negative 3 pi over 4. So all I need to do is find negative 3 pi over 4 in my unit circle. If you look at your unit circle, what's the problem though?
it's tangent, so it's x over or y over x.
Well, that's tangent is y over x, but there's a problem even before we have to use that definition. Are there negative angles on your unit circle? No. Ugh, what am I going to do? Well, not multiply, not divide. Add what? 2 pi to 3 pi over 4. We're going to find an angle that's coterminal to it that will be on our unit circle. To do that addition, I need a common denominator. That common denominator would be 4. Is everybody okay with what I did there?
Yeah.
So now, as Ian had mentioned, tangent, or I'm sorry, tangent is y over x. So I'm going to go to my unit circle. Find the angle, 5 pi over 4. And I'm going to write y divided by x. Everybody feel okay doing that? If I take negative square root 2 over 2 and divide it by negative square root 2 over 2, what do I get? 1, right? If I take a number and divide it by itself, it's just 1. So this guy can replace all of that. Now we have to find the inverse, right? So we're going to do sine inverse of 1. So I know the fundamental range for sine is negative pi over 2 to positive pi over 2. I know here this is sine theta is positive. Sine's positive in quadrants 1 and 2. This guy is covered by quadrants 1 and 4 because it's the same as the problem we just did. So on the unit circle, in quadrant 1, we're looking for where sine, or where y, because we're doing sine, is equal to 1. It is pi over 2. Yeah. So if I go and I look at my unit circle, I look at the y's, boom, there's y equals 1 at pi over 2. See it? You guys feel good so far? So far, so good? Again, not bad, right? It's basically the same thing we've been doing. We're just adding like a little extra layer on. But as long as it's like still kind of the same thing, I dig that, Mr. Kulik. You know, like if it's just like, okay, we have this extra step, and then it's the same thing we've been doing. Or it's like the same thing we've been doing, and then I have this extra step at the end. Like, those are my favorite kinds of problems, where it's like, oh, meet your new problem, same as your old problem. Great. If everything is just like, you know, like doing this inverse stuff, all the problems basically come down to being able to do that, and I just have a little bit of like extra stuff before or after, like I am good. So remember, when we say arc, that's the same thing as inverse. So like arc tan is just tan inverse. So that's the same problem still. Don't be freaked by that. We're going to start on the inside though. So if I want to do tangent at 2 pi over 3, I go to my unit circle and try to find the angle 2 pi over 3, which I can find. That is certainly unit circle angle because it's between 0 and 2 pi. Hi, Ms. Carter.
I'm sorry, is Jacob Reverend there?
Yes.
Can I talk to him for just 30 seconds?
Yes, Jacob.
Sorry.
You're needed in the hallway here for just like 30 seconds.
That's the man.
So I found 2 pi over 3. I'm going to do y divided by x because it's tangent. So there's my y over x. So remember, that's this, a fraction is the same thing as division. And to divide fractions, I just multiply by the reciprocal. And it's going to be negative root 3. Everybody feel okay there? So this guy is negative root 3. So my problem becomes tan inverse of negative root 3. So far, so good. Okay. So I know that tangent is negative. And I know tangent is negative in quadrants 2 and 4. I know the fundamental range for tangent is negative pi over 2 to positive pi over 2. Which again, that's the same, virtually the same range as we saw for sine. It just, they're not or equal to's, but like, that doesn't really matter a whole lot. It's still covering these two quadrants. Is everybody okay? So we're going to be looking in quadrant, on the unit circle. In quadrant 4, we're looking for where y over x is equal to negative square root 3. Now you remember the trick we did last time for this? There's no like just regular square root 3. So let's write it as over 1. But there's not any coordinates on my unit circle that are regular square root 3 and regular 1. But if I multiply this by like a half over a half, there are places on my unit circle where I have square root of 3 over 2 and 1/2 as coordinates. So my y is going to be plus or minus square root 3 over 2. And my x is going to be like minus plus 1/2. Now they can't be the same sign because the fraction is negative. So one can be positive, the other can be negative. So I'm just going to go to my unit circle and look in quadrant 4 for a place where either I have a positive 1/2 or negative 1/2. So I'm looking in quadrant 4, my x, there's x is 1/2, y is negative root 3 over 2, so I want 5 pi over 3. I think we saw the same problem earlier. What's the only hiccup here?
It's not in between that.
Yeah. It's not in there, right? What do? Subtract 2 pi, just like we did before. I'm going to write 2 pi as with a common denominator straight away. So I get negative pi over 3. And that guy will work, right? 1/3 is 0.3, so negative 0.3 is between negative 0.5 and positive 0.5. So far, so good? All right. let's look at the next set of problems, which are almost the same set of problems, but no number. Right? Instead of like sine of arc cosine of a half, we have sine of arc cosine 2x. So our answer for these sorts of problems will very likely have a variable in it. We'll probably have x's or some combination of x's in it. That's fine. Our answer will be an expression more than likely rather than just a number. But we're still going to start kind of the same way. So we're going to start on the inside. Now, here we're going to operate a little bit differently. So cosine inverse of 2x equals theta is the same thing as saying cosine theta equals 2x. Right? Those two equations are equivalent to one another. And I remember using SOHCAHTOA that cosine is adjacent over hypotenuse, right? So here's my right triangle with angle theta. The adjacent side should be 2x, and the hypotenuse should be 1. Because cosine is adjacent over hypotenuse. Now what I'm going to do is find that third side in terms of x's. Ellie, what's up? Sure. So I know because we have a right triangle, I can use the Pythagorean theorem. So 2x squared plus y squared is equal to 1 squared. What is 2x squared? 4x squared, right? 2x times 2x is 4x squared. And 1 squared obviously is just 1. So to get the y by itself, I'm going to subtract that 4x squared from both sides. Everybody feel good so far? And we want just y, not y squared. So what do we have to do? We'll square root both sides. Remember, when you square root both sides of an equation, it creates a plus or minus. But what is y representing?
The distance.
A side length of a triangle. So what can we say about it?
It's always positive.
It has to be positive. Yeah. So far, so good? All right. This triangle is what we really need to finish the problem. That was the hard part. So if cosine inverse of 2x is theta, I just really need to compute sine of theta. I remember from SOHCAHTOA, sine is opposite over hypotenuse. If I look at my triangle, the side opposite is root 1 minus 4x squared. And the hypotenuse is 1. That's my answer. So again, the hard part is building that triangle. Once you've built the triangle, though, it's just SOHCAHTOA. Yes, Ian.
Wait, never mind.
Okay, let's do it again, right? Luco?
Can you simplify 1 minus 4 to the square?
No. Square roots do not distribute across addition and subtraction. Right, if I have like, 9 minus 4 is 5. If I take the square root of 9 minus 4, I can't do square root of 9 minus the square root of 4, which would be 3 minus 2, which is 1, which is not the square root of 5. That's what you're thinking?
Yeah.
Okay, yeah, so don't do that. Good
So,
question.
If we had a problem like this, we can put 1 minus 2x.
Correct. That does not simplify to that. Those two things are not equal. All right, let's do one more. So again, we start with the inside. And we're going to rewrite that as a sine equation. And we're going to use that to build a right triangle because I know that sine is opposite over hypotenuse. Everybody like what I've done so far? I need to find that third side of my right triangle now. I'm going to call that y. To do that, I'm just going to use the Pythagorean theorem. So I have 2 minus x squared plus y squared equals 1 squared. What's 2 minus x squared? How do I do that?
4 minus.
It is not 4 minus x squared. Oh, no. I have to FOIL that out. I have to do 2 minus x times 2 minus x. Now, I'm going to do the foiling quickly in my head. Does anybody object? So it's 4 minus 4x plus x squared. Now all I'm going to do is get the y by itself. So I'm going to subtract over the 4, add over the 4x, and subtract over the x squared. And now that's y squared by itself, but what do I really want? Y, so what do I have to do? Square root both sides. Now, do I have to worry about a plus or minus in this problem? No, why not? It's just a side length, right? So don't worry about the plus or minus. I always want to mention it because, like, forgetting the plus or minus after you square root both sides is like a number one mistake that high school students make when solving anything. We forget our plus and minuses. Oh, Mr. Kulik. All right. So this guy now just becomes cotangent theta. And I know from SOHCAHTOA, theta is adjacent over opposite because it's the reciprocal of tangent, right? So if I go and I look at my angle, adjacent is the square root, opposite is the 2 minus x. So again, the hard part is building out that triangle. Once you've got your triangle built, it's just SOHCAHTOA, right? It's just SOHCAHTOA once you have that triangle built. Super easy, right? Building the triangle is the trick. So the assignment for today is 1 through 18 from the problem set, the book problems. That's all I got for you guys today. What should you expect coming later this week? Yeah, what would it be on?
Worksheet 4.
Yeah, like basically worksheet 4, which is just worksheets 1 and 2 combined together into like one thing. Next. So you'll have the next class we have to do 4-2. Still have a review day coming. So probably test next week.
Yeah, instead of the 4, like over 5 mine already.
Oh, that's probably just I probably made it. I probably picked the wrong week. It's probably the equivalent day next week or something, right? Just grabbed the wrong day.
Yeah, alright.
I'll fix that. Thank you.
Yeah.
Any final questions before I sign off? You guys feel okay?
Yeah.
Practice some of this. Like, try to bang through. There's really, like there's 6 problems basically that are new, that are things that you don't already know how to do. I would start right away on, on some of those, 14 through whatever, then 7, I don't remember now. If you looked at the problems, though, it'll be obvious, like the same ones that we just worked on today.